time for some questions. A few minutes. It's about 7-8 minutes for questions. I'm going to go to the Q&A and read some of the questions there. Here's a very interesting one from Dr. Marinda Smits. How is commercialization of a product or service, which is the output of publicly financed research, justified? Because the infrastructure, HR, and materials would all be purchased with public funds. This is surely unfair competition. What are the commercialization or organizational models used to reduce unfair competition due to the use of publicly financed product development and research? How do the different institutions, NEXA, ARC, etc., approach IP rights and commercialization utilizing public funds? Would you all like to briefly respond to that? Siphelele, can I ask you first? Okay. Or Pradesh?
No, thank you. Thank you so much, Dr. Smart. It's a very interesting question. Yes, obviously, a development of IP within the South African Nuclear Energy Corporation would result, yes, exactly, you're correct when you say it is publicly funded. Some is publicly funded. Some, of course, we do receive funding from institutions, companies, etc., that want us to develop technology for them. Within NEXA, some of it, for example, is commercialized by NEXA. So in other words, like if you look at the NTP radioisotopes, that work that is commercialized via that, or even, for example, Pelchem, the returns on that investment comes back to the state, basically being back to the fact that it's returned to NEXA, which is this publicly funded organization. So the end result of that is NEXA is a 2.4 billion rand organization, but I think our grant from the state is about 800 or 900 million, somewhere in that ballpark. So it kind of gives you an idea of the funds that we generate internally versus funds that we obviously generate via our state grants and, of course, via other sources. So that being the case, it does assist the public in the sense that they do not have to find the full cost to maintain and run NEXA. Obviously, where we do license out IP, again, there is IP agreements, and that IP agreements will result in a flow of funds back to NEXA, so again, back to the state, so that we ensure that the fact the public funded it, the public must in some way or the other benefit from it. Thank you very much.
Thank you very much, Pradesh, for that very short and clear answer. Siphelele or Cynthia, would you like to respond?
Yeah, thank you. In terms of the material that has been publicly financed, we ensure that we follow a transparent process for the parties that are interested to actually commercialize on behalf of us, if that's the process we are following. But we also have other activities where we would have like direct sales on some of our material, which is also publicly financed. We do provide services on other cases, which gets dealt with in a different way. If it's R&D activities, then it will fall under full cost. Thank you.
Okay, thank you very much, Cynthia. Mike Satehe.
Yes, thanks, CEO. So I do agree with both Cynthia and Pradesh that commercialization is not at the expense of making the institution richer, but to plow back, for instance, in ourselves as a research infrastructure, would get seed funding for building it, but to sustain and the OPEX, it would have to be on our own for us to do new projects and train more PhD. So then we have to actually try and get products that we can commercialize, but also to make sure that South Africa is not a consumer. If we get really a life-changing radiopharmaceutical, of course, the other countries must actually purchase it from us, and that's how it should go.
Right. Yes. Siphelele, would you like to respond?
Thank you, Yancy. Can I ask that you please repeat the question for me? I didn't get the question.
Oh, certainly. The question is whether commercialization by publicly funded institutions isn't unfair competition because it's making money.
Oh no, I do agree with the colleagues, though I'm not in that space specifically, yeah. But I do agree with what the colleagues have submitted. Thank you.
Okay, thank you very much. Yes, there is of course the publicly funded research Act as well, and that stipulates very carefully, where the proceeds from publicly funded research should go to, and how there can be shared agreements of the benefits of that. It's quite a difficult position in which science councils find themselves in, that they are expected to generate their own revenue. So they get a small parliamentary grant, which doesn't increase very much, and it really is a constraint within which they work. And then they're expected to generate business to raise the funds for their own research and development of products. So it is an enormous challenge, I would say, as opposed to an advantageous situation where they benefit greatly. There's a question, will the presentations be shared with us? Yes, the presentations will be on the NSTF website. So please have a look at that on the event page, which there's a link in the chat. And then I'll go to Busisiwe Alant, who said, thank you very much indeed to Cynthia. I would like to know about the regulations and legislation pertaining to Indigenous knowledge IP rights with respect to the use of Indigenous traditional medicinal plants to develop therapeutics for various ailments. Cynthia, would you like to respond to that?
Yes, thank you, CEO. In South Africa, we have what we call NEMBA Act, which looks into benefit sharing and material transfer. It covers the issues around traditional use. Like, for an example, if there's a community that was involved to develop a therapeutic something for ailments, it means the communities will also be recognized. So there's a whole process that we normally follow with the Department of Environmental Affairs. It starts from disclosing when you are busy with the discovery phase up until the process, the product is there, and there's an issue of the permit as well that one needs to follow in order to ensure that the indigenous knowledge is protected and parties who were involved, they are also recognized, and just normally it falls under the Nagoya Protocol. Thank you.
Okay, thank you very much. Also related to that, Charlotte Mashaba asks, in terms of the review of the IPR Act, the review has been ongoing, but I would like to know which sections would you propose to be amended? Also to Cynthia. Is that something you can answer for us?
Not now.
Or rather not.
Thank you.
Okay. That is to be seen, I think. It might help if we put a link to the IPR Act. In any case, that does seem to be another discussion for another day. Gordon Branson said, thank you to both presenters, the first two presenters, for the insightful and articulating the current research, development and innovation challenges. My question is focused on the importance of preventative services to reduce cancer within the population. What is the current disruptive strategy to reduce cancer at scale in South Africa? Thank you. And that is a question to Mike Satege.
Thanks, CEO. I think it's a very important question, and in all what we do, clearly, preventative measures are really the thing we should be striving for. And then for us to do that, education and knowledge is really key to this, but primary healthcare is also essential. As people are really presenting, they have to present closer to their places of need, and they, in that way, when I say education and communication, it goes both ways, to the patient and to us as colleagues. So the colleagues have to know for good science and when to therefore refer early for imaging. So education and early imaging will be very key in terms of preventing some of the signs that might be leading to cancer, such as we are doing with pap smear. I mean, if we are doing a pap smear, and really it's clear that we get it at the CIN level before it converts to cancer. So we can't do better than innovative collaboration. Innovative advocacy and perhaps, if I may say, it's futuristic as well. There is what we call liquid biopsy, tumor circulating DNA. Now that might actually change something like that. It will be in a form of a serum. Now you present at a doctor, and then it doesn't have to be an oncologist. Then they would take blood, and then if it shows some various or multiple cancers, doesn't have to be one cancer, such as. So then it will say, okay, there are alarming circulating cancer cells, and then therefore you take appropriate actions for imaging. So that is coming. Its reliability needs scrutiny and rigorous proving. You don't want to raise an alarm, but that's going to be the thing that would help us.
Oh, very interesting indeed. Yes. In your presentation, you also highlighted that public awareness is very important and the communication with the public. Earlier on, there was a question. Thank you for the interesting forum. Will the upskilling and reskilling in AI and data science of the research community also be discussed? And this is from Janine Wickman. Professor Teche did refer to AI and that needs to be taken on board because AI can help with cancer diagnostics and treatment. But I think it's very much at the beginning still. Mike, would you like to respond to that?
Yes, CEO. So it is at the beginning, but yet somewhat implemented already. If we look into, for instance, let's take the pathologist, it is really terrible for them to be looking at those small mitotic cells to say this is a cancer slide or a not cancer slide on that microscope. So if we teach all those machines, which is already happening in other places, then it takes that onerous work, tedious work out, and then it can actually tell you that indeed this is, and therefore the pathologist can confirm and also stage it further to see how prognostically significant it is. So that, and then for instance, coming to drug discovery, to really have molecules, various molecules that are there, say hundreds of them, to sift through after we have simulated the molecule. So AI is already happening at that stage. So computational chemistry, it's already happening. And then it then selects your top 5 or so, then you work out of those. And then coming to imaging already in terms of us interpreting already, and those choosing, and in terms of radiation therapy, you then have the computer that will draw the lesions that are abnormal for you, and then segmentation can be a problem to draw those lesions. So doing that already by computer saves time, and it helps with the accuracy, and therefore it's getting closer and closer to being a routine if we just have to actually look at it well. But as we speak of AI, we also have to be cautious about then experts in certain fields has to come, because it shouldn't be just a generalization of things. It has to be really well re-educated and re-evaluated all the time. But certainly it's already indirectly happening. Perhaps some of it we just don't call it AI, but it's fragments of it.
Right. Thank you very much for that response, Professor Teche. We will be having a discussion forum in October on 4IR technologies, and I'm sure that these issues will be on the table again, certainly with the use of AI in various respects, in various disciplines across the sciences and technology.